Hello everyone, this is Sai Teja, a data science and business analytics intern at the Sparks Foundation. Today I'm going to present you the Task 2, which is prediction using unsupervised machine learning. The objective of the task is to predict the optimum number of clusters present and visualize them. So the first thing that we do is import all the required libraries, and after that read the data from a CSV file. We can see that there are 5 columns, out of which 4 are numerical and the other one is the categorical column. So if you look at the shape, we have 150 rows and 5 columns. The data type would be float and object. So over here we can see that there are 0 null values, which is pretty good. And after that, I have used a pair plot to get the relationship between all the different combinations of the variables. Uh, so we have 4 numerical columns in our data set, right? So here we got all the 16 combinations of them. Uh, it is always helpful to visualize the data. And after that, I've I've calculated the correlation and tried plotting a heat map using the same. So over here we can see that there are some positive correlation values and also some negative correlation values. So after that, we'll be trying to find the optimum number of clusters using the elbow plot. So for that, I've removed the categorical column from the data set and tried converting it into a 2D NumPy array. So the next step would be finding the sum of square error by changing the number of clusters. I've taken the number of clusters from 1 to 10 and calculated the uh, sum squared error. So if you look at that, it would be in this format. So once we have got the uh, sum of square error, we'll try to plot it. So the plot would be looking like a elbow. So the optimum number of clusters are formed where the elbow is occurring. So in this case, the elbow occurs at this point, so which would be 3. So we can say that the optimum number of clusters are 3. So once we have got the number of clusters, we'll go ahead and calculate the K-means. So over here, I've kept the number of clusters as 3 and calculated the K-means. So what K-means actually gives is an array of all the clusters. So it will actually divide our data set into 3 clusters, which are 1, 0, and 2. So I've added this k-means to our original data frame so that we can find out which row falls into which cluster. And after all of these, now it's time to visualize the clusters. So I've tried plotting the first 2 columns, which are sepal length and sepal width, in a scatter plot. So here we can see that there are 3 clusters. Mm, and after that, we can also try plotting the cluster centroids. Centroids are nothing but the center point of the clusters. So after that, I plotted the centroids again along with the entire data set. So similarly, I've also plotted the third and fourth column, which are petal length and petal width. So yeah, so in this way, looking at all these graphs, we can conclude that the optimum number of clusters are 3. Thank you.